This is a look at a limiting reactant problem. Now we identify it as a limiting reactant problem because the mass of each reactant is given. Now, there's more than one way to solve a limiting reactant problem. This is the way that I prefer to do it. The way that I prefer is to start with the mass of each reactant given. So we have the 36.3 grams of aluminum and the 54.7 grams of the sulfuric acid. And in each case, we wind up wanting to convert 2 grams of aluminum sulfate. Now we're going to wind up calculating two answers, one here and one here, and in the end, we will wind up selecting the smallest of those two answers. So, let's go ahead and get started. We'll start with the 36.3 grams of aluminum, and the first step on this one is to convert this quantity to moles. So we'll place the 1 mole of aluminum on top. On the bottom, we put the molar mass of aluminum. We look it up on the periodic table. We see that the atomic mass for aluminum is 26.98 AMUs, which means we have 26.98 grams of aluminum in every 1 mole. Grams of aluminum cancel out. Now again, we're trying to work towards aluminum sulfate. So to get over to aluminum sulfate, we need to use the molar ratio and relate moles of aluminum to moles of the aluminum sulfate. So we put the moles of aluminum on the bottom and the moles of the aluminum sulfate on top. To get the numbers out front, we look at the coefficients on the balanced chemical equation. And we see that we have 2 moles of aluminum for every 1 mole of aluminum sulfate. Moles of aluminum cancel out. At this point, we have just one more step, and that step is then to convert moles of the aluminum sulfate over to grams of aluminum sulfate. So we put the 1 mole of aluminum sulfate on the bottom. We put the molar mass of aluminum sulfate on the top. That molar mass works out to be 342.17 grams. Now we get that by summing together 2 aluminum atoms, 3 sulfur atoms, and 12 oxygen atoms. Simply looking up the atomic masses on the periodic table. Moles of the aluminum sulfate cancel out. And if we go ahead and run this through our calculators, we take 36.3 times 342.17 divided by 26.98, divided again by 2, and we wind up with an answer of 230 grams of the aluminum sulfate. Now again, this is just one of the two answers we're going to calculate. We also have to work with the quantity of 54.7 grams of the sulfuric acid. Now just like the part above, our first step in this one is to convert from grams over to moles. Let me move this down just a bit here. There we go. And so to convert from grams to moles, we say that for every 1 mole of the sulfuric acid, we have a mass. We sum together the mass of 2 hydrogens, 1 sulfur, and 4 oxygen. We wind up with 98.09. And again, that's the number of grams contained in 1 mole of the sulfuric acid. Next, we need to relate the moles of sulfuric acid to the moles of the aluminum sulfate. We do this by going back to the balanced chemical equation and we see that there are 3 moles of the sulfuric acid for every 1 mole of the aluminum sulfate. And again, we get these quantities by looking at the coefficients in the balanced chemical equation. At this point, moles of the sulfuric acid cancel out. Then we can convert from moles of the aluminum sulfate to grams of aluminum sulfate by putting the moles of aluminum sulfate on the bottom, the grams of aluminum sulfate on top. Well, this number hasn't changed. We see above that that value is 342.17. At this point, moles of the aluminum sulfate cancel out. If we run this through our calculators, we'll take 54.7 divided by 98.09 divided by 3, and then multiplying by 342.17. Upon doing so, we wind up with an answer of 63.6 grams of the aluminum sulfate. Now again, what we said we'd do is we'd compare these two answers. We have 230 and 63.6. Well, turns out we can only make the 63.6 grams of the aluminum sulfate because once we get up to that amount, we are going to run out of the sulfuric acid. So this here, the sulfuric acid, is going to be the limiting reactant because it limits us to producing only 63.6 grams of the aluminum sulfate. Now another name for this quantity here is called the theoretical yield. Next, suppose we'd like to find out the percent yield if 58.8 grams of aluminum sulfate were actually produced. Now, percentages always work the same way. Percentages are always found by taking the part over the whole and then taking that result and multiplying by 100. Now, in terms of yield, we say that the part is called the actual yield. So we say that the percent yield is equal to the actual yield. So again, that's the part. The theoretical yield is the maximum amount we could have made had all of the limiting reactant been converted into product. And so we think of that as the whole. And then we take that result and multiply by 100. So in this case, the actual yield would have been the 58.8 grams. The theoretical yield was the 63.6 grams. And so if we take one divided by the other, and of course if we really had the complete units, we'd have the grams of aluminum sulfate on both the top and the bottom, blah, blah, blah. But those units are going to cancel out anyhow. So we take 58.8 divided by 63.6, and we wind up with an answer of 92.5% yield. And this then would be a percentage yield calculation.